So this video will cover sections 3.2, 3.3, and 34. And so these various sections deal with different ways of finding derivatives, so differentiation rules. So for example, let's start out with this one. Let's say we have y equals 2x plus 2 times x plus 3. So far based on what we know if we had this where we multiplied out that we could do this, so let's do that. So if I multiply this out, you would end up with 2x squared plus 8x plus 6. Right? And now that it's in this form, it's easy enough to find the derivative, because the derivative here is going to be 4x plus 8. Right? So that would be my derivative. Well, we now get in terms of the various rules they have. One of the rules is what they call the product rule. So we have the product rule. And so now, if my function, and we use capital F, is given by a little f of x times g of x, then my derivative is given by f of x times the derivative of g plus the derivative of f, the first one, times the second one. And that is our product rule. So now let's do the same problem we just did and find the derivative, but now using this product rule. So again, we go back to what we had. We had y was equal to 2x plus 2. And then x plus 3. So the product rule says break it out into pieces. So let's call f of x 2x plus 2. G of x is going to be x plus 3. So those are my two pieces. Now we want to take the derivative of both of those. So f prime is going to be 2, and g prime is going to be 1. And now we're going to just take the pieces and plug it into the format for the product. So my derivative, and let's actually do it y prime, is going to be the first one times the derivative of the second one plus the derivative of the first times the back piece. And for this one, let's multiply this out just to prove that we do get the same answer. So 2x plus 2 times 1 is just 2x plus 2. 2 times that is going to be 2x plus 6. Combining and simplifying, we end up at 4x plus 8, which is the same result we had earlier. So let's go through another example of this. So another one. And this time, let's say we have is going to be 4x cubed minus 7x squared plus 5x times x squared plus e to the x. So again, we want to break it out into the pieces. So we'll call little f is going to be 4x cubed minus 7x squared plus 5x. G will be x squared plus e to the x. Take the derivative of the two pieces. So the derivative of the front piece is 12x squared minus 14x plus 5. And the derivative of the back piece is going to be 2x plus e to the x. So again, we got all our pieces, and the next step then is just to plug those into the format for our product rule. So my derivative is the first to 7x squared 5x times the derivative of the second piece plus the derivative of the first times the, and for what we're going to do, we're going to leave the result in this form. So we will leave the answer in this form. Right? So you don't have to worry about multiplying this all out, combining, simplifying, and all that. Okay? But again, if I gave you a value of x, you can find this slope for this curve at a particular point. Okay? So that is the product rule. And so the next thing then, well, what happens when we divide stuff? So let's say, what would happen if we had f of x was equal to 2x squared plus 8x plus 6 divided by x plus 3. Well, that should look familiar because actually those are the things I used in the very first problem we did. And so we go back. I know that if I multiply those two together, I get this. And so if I take this and divide by either one of these things, I should get the other, right? And so if I take this and divide this by x plus 3, my answer will be 2x plus 2. So I know this is going to simplify to 2x plus 2. And I then know that the derivative of this will be 2. Right? Well, we did the product rule, and so this is a fraction, which means we're now talking in terms of the quotient rule. And so we get in terms of that. So in terms of the quotient rule, again, we're going to divide f into pieces. So f of x divided by g of x. And my derivative is given by the first, the bottom term times the derivative of the top minus the top times the derivative of the denominator all over the denominator squared. Right? That's the quotient rule. Right? Now, the product rule, go back a bit, is natural argument is pretty easy because after all, it doesn't really matter how I do this. I can flip these around. But again, because this is multiplying and adding, it doesn't matter the order you do it. But quotient rule, it does, because quotient rule, we are dividing and we are subtracting. And so order does matter, so you got to make sure you plug it into the quotient rule correctly. So let's do the same problem, but now use the quotient rule and see if we get the same answer. All right. So let's say that f of x is given by 2x squared, 8x plus 6, over by x plus 3. Okay. So again, quotient rule says divide it out each of the pieces. So the top piece we'll call little f of x. So 2x squared plus 8x plus 6. G is going to be the x plus 3. The derivative of the top is going to be 4x plus 8. And then the derivative of the bottom is just going to be 1. So we have all the pieces. Now the next thing is to plug it into the format for my quotient rule. So my derivative, big F here, is going to be the bottom term times the derivative of the top minus the top term times the derivative of the bottom all over the bottom term. So let's actually go through this and simplify this just to prove that we do get the same answer no matter which way we do this. Right? So the first thing we're going to do is take care of doing our multiplying here. So remember that's FOIL method. If I multiply those two together, we get 4x squared plus 20x plus 24 minus, this times this is just going to be the 2x squared, 8x plus 6, all over x plus 3 quantity squared. Right? So now we can simplify the top. So my top will become, well, 4x squared minus 2x squared, that's 2x squared. 20x minus 8x is 12x. And 24 minus 6 is going to be 18 over x plus 3 squared. So we end up with that. And so now, continuing this, we get that this is going to be 2x squared, 12x plus 18. If I multiply this out, I get x squared, 6x plus 9. And you can see that the top is twice the bottom. So again, my answer is 2. Right? So either way, I get the same answer. So let's do another example. This. And so this one, let's have this. We'll have, it's going to be 5x squared minus 9x plus 2 over 8x plus e to the x. So again, we'll divide it out into our pieces. So little f is 5x squared minus 9x plus 2. G is going to be 8x plus e to the x. My derivative of the top is 10x minus 9, and then the derivative of the bottom is 8 plus e to the x. Right? So now that we have all the pieces, we will plug that into the format. And so my derivative is going to be the bottom term times the derivative of the top minus the top term times the derivative of the bottom all over the bottom term squared. And like the one we did in the product rule, we will leave the answer in this form. Right? So we have in terms of the product rule, we have in terms of the quotient rule. Other properties that go through is the x set which is the derivative of the trig function. And this comes out of the book. Right? So you have in terms of derivative of sine, cosine, tangent, cosecant, secant, and cotangent. Okay? If you were going to know any of these, well, the only one everybody remembers are the first two, sine and cosine. Okay? But in terms of how these ones work, so for example, let's find the derivative of y equals 9x squared plus sine x. So my derivative, y prime, well, 9x squared is just 18x. The derivative of sine, going back to this table, is cosine. And so we get this will be cosine x. Another example. Let's do y equals tan x sine x. So this is product rule because it's those two are being multiplied, so we divide it into pieces. So this is tan x. G is going to be my sine x. Going back to our table, we find the derivative of tangent is secant squared. So my derivative of tangent is secant squared. So f prime is secant squared x. And then we had earlier, derivative of sine is cosine. And again, now that we have all the pieces, we get that my derivative is going to be tan x cosine x plus secant squared x sine x. And again, we will leave it in dot form. Okay. So we get in terms of finding derivatives of trig function. And again, maybe you'll have this because, again, the quizzes are open book, open notes. So you don't have to memorize that. Again, if people, you're going to know those two in terms of sine, cosine. Next rule for derivatives, chain rule. So chain rule, you got that f of x, capital F of x, is f of g of x. Right? And my derivative then is given by f prime of g of x times the derivative of g. So we get that. So it looks confusing and complicated, but let's go through an example of how this works. Right. So for example, let's say we got this y equals the sine of 3x squared plus 2x. And I want to find the derivative. So first off, we got sine. Well, the derivative of sine is cosine. Then we keep this the way it was. And then we take the derivative of this piece, which is 6x plus 2. Right? And then in terms of convention, because again, for sine, cosine, any of those trig functions, logarithms, and that sort of stuff we'll get to, you have to be taking the sine of something, the cosine of something. And so, for convention then, that last piece, we will just move out front. And we end up with that for our answer. So we get, that would be my derivative. Right? A couple other examples of this and how this works. So y equals cosine of 5x. Well, the derivative of cosine is negative sine. Keep the angle the way it was, which is 5x. And then the derivative of 5x is 5. Right? And then what we would do, again, is to simplify this, it would become this. Right? And that would be my We can also use this rule in regards in combination with the power rule. And so one example of this rule is given something like this. Minus 2x to the 5th. Right? So we want to find the derivative. And so by the power rule, we said this comes up front. This stays the way it was. Drop the exponent by 1. And then we take the derivative of what was inside. And we get that. And we will do a little simplifying. In that I can take this 5 and multiply it by the back piece. And sum my derivative. And 60x to the 11th minus 10 times x to the 12th, 2x raised to the 4th power. So we end up with that. And then one more. So we could have like this, y equals 5x squared e to the 2x. Product rule, because we're multiplying. And so we say, okay, break it out into pieces. This is 5x squared. G is going to be e to the 2x. The derivative of the top piece, this piece is 10x. The derivative of this piece is e to the 2x, but then the derivative of 2x is 2. So we end up with that. We plug it into the format, and we get y prime is going to be 5x squared, 2e to the 2x, 10x times e to the 2x. Combine and simplify a little bit, we get 10x squared e to the 2x plus 10x e to the 2x. And we're done, and we have our derivative. Okay. The other table they give you in there, and we're not going to worry about for this class, is they do give you the table for the derivatives of the inverse sine, cosine, those sorts of things. But we're not going to worry about that for this course. And with that, that will conclude this lesson.